Theoretical recap. A port is a logical endpoint at the transport layer, layer 4, that allows a host to run multiple network services simultaneously. This is the multiplexing concept you studied in the previous lesson. When you connect to a web server on port 80 or 443, or query DNS on port 53, your operating system is directing traffic to the right service using that port number. Nmap, Network Mapper, is an open-source reconnaissance tool that probes a target host or network to discover which ports are open, filtered, or closed, and which services and versions are running behind them. It operates primarily at layers 3 and 4, sending crafted TCP/UDP packets and analyzing responses. A common beginner mistake is confusing the 3 port states. Open, a service is actively listening; closed, the port is reachable but no service is listening; and filtered, a firewall or rule is blocking probe packets, so Nmap cannot determine the state. Another frequent error is running aggressive scans, A or T5, on targets without authorization. Always work on explicitly authorized environments. A minimal mental model. Nmap sends a SYN packet to a port, receives a SYN ACK if open, completing the TCP handshake knowledge you practiced with Netcat, a RST if closed, or silent/ICMP unreachable if filtered. Keep this model in mind as you interpret scan results throughout the workshop. Workshop brief. This workshop directly builds on your work with ports, multiplexing, TCP/UDP, and traceroute. Your mission is to use Nmap to perform a structured port scan campaign against an authorized target environment, document your findings methodically, and produce a concise reconnaissance report. The goal is not simply to run a command and copy output, it is to understand what you are seeing, correlate it with your knowledge of protocols and services, and begin thinking like a security professional conducting the reconnaissance phase of a pen test. You have 4 hours to complete this workshop and must submit your solution before the deadline expires. You are free to consult all previous course materials, lessons on TCP/UDP, ports, traceroute, OC layers, and any legitimate internet resources such as the official Nmap documentation, man pages, and security community references. You may work alone or ask for help, but the analysis and the final written report must reflect your own understanding. Environment setup. Work exclusively on an authorized target. Acceptable options include 1. A local virtual machine you control. A Metasploitable 2 or DVWA instance is ideal. Set one up using VirtualBox or VMware if you have not already. 2. A deliberately vulnerable cloud lab such as TryHackMe or HackTheBox's free starting rooms. Or 3. Your own local machine. 127.0.0.1, to understand how Nmap behaves on local host. Under no circumstances scan hosts or networks you do not own or have explicit written permission to test. If you are unsure whether a target is authorized, choose localhost or a local VM. Install Nmap on your workstation if it is not already present, available for Linux, Mac OS, and Windows. Verify the installation by running Nmap version in your terminal. Steps to complete. Begin with a basic scan of your target to get a first overview of open ports. From there, progressively refine your approach. Perform a scan limited to the top 100 most common ports, then expand to a wider range. Experiment with at least 3 different scan types that Nmap supports, for example, a default TCP SYN scan, a version detection scan, and a UDP scan on a small port range. For each scan you run, note the exact command used, the time it took, and what changed in the output compared to the previous scan. Once you have identified a set of open ports, look up each service you find. What protocol does it use, at which OC layer does it operate, and what is its typical role? Cross-reference your findings with the port knowledge from the previous lesson, ports 80, 443, 53, 22, 21, 25, etc. Pay particular attention to any unexpected open ports, these are the most interesting from a security perspective. Try to explain why a given port might be open on your target and what risk it could represent if the target were exposed on the internet. Finally, run an OS detection or service version scan, use the appropriate Nmap flags on your target and observe what additional information Nmap can infer. Reflect on how an attacker could use this information in a real-world scenario, and conversely, how a defender could use the same tool to audit their own exposure. Deliverable, Reconnaissance Report. Your submission must include a written report of at least 400 words structured as follows. 1. A description of your lab environment and the targets you scanned. 2. A table summarizing all open ports found, the service identified, the protocol, TCP/UDP, and the OC layer concerned. 3. The exact Nmap commands you ran with a brief explanation of the flags used and why you chose them. 4. A short analysis of at least 2 open ports, explaining the associated service, its normal use, and the potential security risk if misconfigured or exposed. And 5. A personal reflection on what surprised you, what was difficult, and how this reconnaissance step fits into a broader pen test workflow. Do not just paste raw Nmap output, interpret it. The quality of your analysis matters more than the quantity of scans. If you encounter a difficulty, Nmap showing all ports as filtered, a VM not responding, etc., document the problem and the steps you took to troubleshoot it. This is itself part of the learning and will be valued in the evaluation.